Okay, on page 540 you had to plot some complex numbers. And remember, complex numbers are of the form z equals a plus bi. And you can plot them on a rectangular coordinate grid. The only difference is, instead of the x-y axis, we call them the real axis. So this is the real axis, the x-axis, and this is the imaginary axis up there. So we have the real axis and the imaginary axis for our graphing. And then you can just, let's take a couple sample numbers. So suppose I have z equals 3 plus 2i. How do you think I would plot that? We'll start at 0, 0, go over 3, 1, 2, 3, and up 2i. And there's our point z. Here, let's label it z. All right, or z sub 1. All right, let's do z sub 2, and let's call that minus 3 plus 4i. Where do you think that is? Start at 0, 0, minus 3, 1, 2, 3, up 4i, 1, 2, 3, 4. There's z sub 2. All right, let's try another one, z sub 3. How about this one? 2 minus 3i. You think you know where to plot it? Stop the video and try it first, and then see if you're right. Okay, here we go. So 2 over 2 down 3i, 1, 2, 3. And there we go, and there's z3, and I've plotted the point. All right, the next thing you're going to have to do is to write a complex number in trig form. So I'm going to show you how to do that next. Okay, so to write a complex number in trig form, there's a little process. All right, here's a complex number, z equals negative 2 minus 2 root 3i. To write that in trig form, first of all, you have to know what trig form is. So trig form looks like this. Z equals r times cosine of some theta plus I sine of some theta. So, how do I go from this form to trig form, all right, or complex form to trig form? Well, the parts you need to know what is the r, and r is defined as the square root of a squared plus b squared. Remember, from trig form, complex form is a plus bi. That's the general form for a complex number. So my a and my b are right there. So for this particular number, right, I do the square root of a, which is negative 2 squared, plus the square root of b, which is negative 2 root 3 squared. And I figure that out. So 2 squared, 4. Negative 2 squared, 4. Negative 2 root 3 squared is 4 times 3 is 12. So I get square root of 16, which is 6. So r equals 6. All right. Now I also have to find the theta, right? I need r and I need the theta. And the theta is easy because we know that the tangent of theta equals b over a. So do I know a and b? Oh, yes, I do, right? So I do the b, which is negative 2 root 3 all over a. And then I do tan inverse of theta, negative 2 root 3 over negative 2. Sorry about that, negative 2. And use your calculator to figure that out. And again, you can just plug that into your calculator and you get the theta equals approximately 74.5 degrees. So now, what is the trig form of the number? All right, the r is 6 and the angle is 74.5, so now I just write it. 6 times cosine 74.5 plus I sine 74.5. And that should be it. There you have trig form from complex form. Here's complex, here's trig. Note the difference. You should be able to convert back and forth. Good luck.